As little kids, most of us used to stare into the skies and wonder about vast and distant galaxies and stars. We tend to have neither time nor desire to stargaze nowadays. Why did most of us lose curiosity about the hidden mysteries of outer space? Astronomy has been a quite ambiguous discipline in the public eye since its dawning. It's been closely connected to astrology, which is now considered a pseudoscience. Although astronomy and astrology divided a while ago, it left so many people biased and confused these days. How many times shall we hear, astronomy? I heard of it. Isn't that about constellations and fate predictions? Though, to define differences between astronomy and astrology, and also to determine the degree of astronomy's importance, let's dive into history. Long before becoming an object to explore scientifically, the sky was a cultural resource among many peoples throughout the world. Most ideological systems were heavily based on linking the celestial bodies to certain events, in both the terrestrial and the divine worlds. The appearance of somewhat fundamental knowledge of mathematics and astronomy was based on economical necessities. To regulate agricultural works, people had to invent a calendar to determine the proper time for planting the crops. To invent a calendar, they had to watch the celestial bodies for a long time. Moreover, to run a convenient accounting system for economic activities, people had to establish counting systems. That, in turn, inevitably gave rise to the development of early mathematics, including geometry that was important for organizing land use. The first observers of the celestial bodies were the ancient priests. They discovered some patterns in the skies, and watching them, they tried to connect them to the will of gods. The Mayans and the ancient Egyptians built the first observatories and made the first constellation maps. The ancient Greeks were the first to take a scientific approach towards observing the night sky. They developed the earliest models of the universe founded on empirical evidence. They deemed space and time to be eternal and infinite, and our planet seemed spherical and stationary to them. One of the most famous works of the 2nd century AD was Syntaxic Mathematica, well known as the Almagest, written by Ptolemy of Alexandria. By his astronomical observations, he proved the said model true. Although not all Greek astronomers accepted the geocentric model of the universe. The first person to even propose the heliocentric model of the universe was Aristarchus of Samos. The description of his conception was found in Archimedes' book, The Sand Reckoner. A series of important discoveries were made exactly in that period. Even though the precision of those discoveries was striking, they had to be revised and corrected over the years to reduce the errors of measurement or verify the existing concepts. We'll scrutinize one of the most exciting earliest scientific events and its further development. Then, we'll return to the general history of astronomy. Eratosthenes of Alexandria, Greek astronomer, mathematician, and geographer, was the first to measure the size of the Earth. All of a sudden, he noticed that the ray of sunlight penetrated the deep well in Sienne on the days of the summer solstice. He measured the zenith angle of the sun and realized it was 1/50th of a full circle, or 7 degrees. That was how he got to determine the radius of the Earth. As he assumed that the rays of the sunlight were parallel due to the distance between the sun and the Earth, he declared that the circumference of the Earth is approximately 50 distances between Alexandria and Sienne. The units of measurement he used were stadia, so this is the reason we'll never know the precise results of his measurement. However, it is estimated that his measurement uncertainty was even less than 10%. Then, St. Augustine decided that it was unholy to deem the Earth spherical. He considered it nonsense that there were the descendants of Adam walking with their feet opposite to his own, so he declared that the Earth was flat, and that conception was corrected only in the late Middle Ages. Then, in 1670, a French astronomer, Jean Picard, made a bit more exact measurement Using the same method as Eratosthenes, he measured the length of an arc of the meridian between Paris and Amiens. It was difficult to measure the distance between them precisely, so Picard used the method of geodesic triangulation. Briefly, he measured the angles between benchmarks, which were various hills and towers, and those benchmarks eventually formed a chain of 13 triangles. The base he used was a road about 11 kilometers long, and the value he got for the radius of the Earth was 6,329 kilometers, which is incredibly accurate. So his measurement error was only about 0.5%, since the polar radius is slightly over 6,357 kilometers. In the 18th century, a group of French astronomers decided to repeat the measurements, taking a longer baseline. At this time, they strived to determine the standard unit for the metric decimal system. They also hoped that the system would be adopted by other nations, so they decided to base it on something universal. What can be more universal than a measurement unit based on the size of the Earth? The astronomers decided that meter would be defined as a 10 millionth of a quarter of the Earth's circumference, but they made a mistake in their calculations. So now the meter is a bit less than it was intended to be. Owing to the future cosmic measurements, the scientists were able to find out that Earth wasn't exactly spherical, because it is flattened at the poles. As a result, they introduced a new word, geoid, which now described the shape of the Earth. So, we're going back to our chronology. Astronomy was developing quite rapidly and profoundly in ancient Greece, right until the 1st century BC. Then, astronomy nearly stopped its progress. However, astrology began spreading from Babylon. Put it mildly, astrology is a practice based on a system of beliefs that all events, including all circumstances dependent on human actions, are influenced by the position of celestial bodies. At first, astrology and astronomy were inseparable, as they both based on various discoveries and calculations. But all of a sudden, astrology took a more mystical turn. People trying to forecast the future haven't tied numerological and geometrical aspects of astrology. Briefly, astrology doesn't necessarily have a negative connotation for the scientific world, since initially it was an incentive to develop many sciences. But weird enough, every time astrology was becoming popular, a period of scientific decline occurred. Is that some sort of coincidence? So, for approximately 2000 years, astronomy stayed at a dead point. The philosophers returned to the concept of the geocentric model of the solar system. The first person to revive Aristarchus of Samos' heliocentric model was Nicolaus Copernicus. Also, mainly owing to him, we know that the concept of Earth rotation was discussed circa 450 BC by Philolaus. It might be worth mentioning that these times religions had a great influence on the development of scientific theories and societal life overall. Remember that lad, St. Augustine, who refused to believe in the spherical form of the Earth? Well, in the Middle Ages, everyone who tried to propose new theories, which were objectionable for the Church, was heavily judged. Sometimes it led to the death penalty. As an example of the Church being absolutely barbarian, Giordano Bruno accepted the idea that space was infinite, and it was filled with a lot of stellar systems similar to ours. Unfortunately, he was burnt at the stake in Rome in 1600. Some scientists of the 17th, for instance Isaac Newton and Christopher Huygens, accepted the theories of both Copernicus and Bruno. But there were still some paradoxes that couldn't have been solved until the explanation of general relativity. One of such paradoxes was the assumption that time and space were infinite. The other one was that if all the stars in the sky were so bright as the sun, the nighttime sky should have been as bright as the daytime sky. In 1609, Galileo Galilei, an Italian polymath, invented the first telescope, giving rise to the development of observational astronomy. In fact, he himself wasn't the first to invent such a tool. but he was the first one to use it for watching the skies. In the 18th century, some basic facts about our solar system were discovered. For instance, it was found out that all planets go around the Sun in the same direction, having similar planes of revolution. Also, all planets were confirmed to be turning around their axis. Many astronomers tried to use Kepler and Newton's theories to explain observational astronomy. Kant was the one who made significant discoveries about the Earth's rotation. We know him as a philosopher today, but he explained the reason why the days were getting longer over the years. Laplace worked on the mechanics of the solar system. He wrote a massive work on many regularities the observations had previously discovered. Also, Laplace made a theory about the evolution of the solar system, known as the nebular hypothesis. The details of his theory now form the basis of our understanding that stars condense out a nebula. The 18th century astronomy was also quite notable in terms of observations. For example, William Herschel built the biggest telescope of those days, a 40-foot telescope. Though actually he did his best work on his previous telescope, a 20-foot one. He discovered Uranus. He was the first to get an approximate idea of the location of our stellar system in the galaxy. He also discovered double stars and published catalogues of them. He began to work out the motions of different stars. So, briefly, the observations by Herschel were the ones that brought astronomy into the modern era. The modern era is best described by the term physical cosmology, which was the symbiosis of physics and astronomy. As a science, cosmology is attempting to sort out the mysteries of the universe's evolution. Some of the matters it covers are the life cycle of stars, the birth and the death of galaxies, and the Big Bang theory. So, the beginning of the modern era was marked by Einstein's general theory of relativity. He tried to connect his theory with the structure of the universe. There also were two discoveries that drastically changed our understanding of the universe. Edwin Hubble proved that our galaxy wasn't the only galaxy, and that the Andromeda galaxy was fairly similar to ours and separate. He also proved that all distant galaxies were moving away from each other due to the general expansion of the universe. He showed it having discovered the redshift of spectroscopic light from distant galaxies. He also noted that it didn't apply to the galaxies clustered together. For instance, both our galaxy, the Milky Way, and the Andromeda galaxy are included into the local group in the Virgo supercluster. What is exactly the role of astronomy in the modern world, especially in education? Astronomy forms our cultural experience, as well as any other creative intellectual activity, such as cinema and art. Scientific illiteracy nowadays is equal to the lack of culture, and, akin to any science, knowledge of astronomy builds a fuller notion of our world and our place in it. It is impossible to predict our future with absolute precision, though it is possible to imagine the number of important discoveries and leaps in space exploration. One of the essential aspects of enlightening people scientifically is introducing them to various disciplines, and thus instilling interest to them. Without planetariums and scientific exhibitions, probably there would have never been such remarkable figures as Carl Sagan, Neil deGrasse Tyson, and Lawrence Krauss.